Okay, so we've got this setup here where we told all this information about A and B, that they're moving in opposite directions. So A is moving towards B. Afterwards then we told that B, the direction of it's reversed. Okay, so whereas it was going towards A, after the impact it's now reversed, it's going 2.4. We're not told anything about the speed of A after collision. If you notice, there's nothing in there, right? And even when you look at part A, it doesn't say about working out that speed. It just says calculate the coefficient of restitution between A and B. But when you think about it, coefficient of restitution, the formula involves knowing all of these, doesn't it? All the speeds. So if you want to work out E, you need to know all of these speeds. So we're going to have to work out the velocity of A after. Okay, and the way to do that, of course, is look at the total momentum of the system before and after, because the total momentum before will equal the total momentum after. Okay, so if we just take this base positive in terms of our velocities, so we'll have mass times velocity 3 times 7 plus then 5 times the velocity here, of course that'll be minus 3 because it's reverse direction. Here then 3 times VA plus then 5 times 2.4. Okay, so straight away then from there, momentum before, momentum after, you can get VA out quite quickly, can't you? So work this out on your calculator. 21 there, that's minus 15, so that's going to be 6. 3 VA plus then 5 times 2.4, so you get 12. So then take the 12 over, so you get minus 6 equals 3 VA. So VA will be minus 6 divided by 3, which is equal to minus 2 meters per second. In other words, actually, afterwards, V is also A is also the reverse direction, isn't it? Because that comes out to be minus 2. So the impact of the collision there is that A now is going the opposite way as well. So when we do the Newton's law of restitution, okay, to work out the coefficient of restitution, you can use that formula, can't you? VB minus VA over UA minus UB. Okay, so then E will equal VB, which is 2.4. Take away then VA, which is minus 2, over then UA, which is 7. Take away then UB, which is minus 3. So on our calculator, you get the answer to be at 0.44. Okay. So then we've answered that then, part A, and it says then, after the collision between A and B, the object B collides with a wall which is perpendicular to its direction of motion. Coefficient of restitution between the wall and B is 0.6. Calculate the speed of B after the collision of the wall. Okay, so let's just focus on B. Now remember, B was going, after the collision, was going at 2.4. Let's just maybe draw that out. So before then, the situation then where this is now going, object B is going at 2.4 meters per second, and it's coming to hit a wall, right? Okay, basically it's going to hit a wall, and then afterwards, of course, then once it's hit that wall, well, it's definitely going to reverse the direction, isn't it? Okay, because now that wall is not going to be moving, so it's going to rebound from that wall. But if they tell us that E is 0.6, okay, in the question, we just need to remember, okay, how Newton's law of restitution works, okay. E, remember, you can remember that formula, but also remember speed of separation divided by the speed of approach. Okay, now if you use this formula, it's possible to do that by thinking of this as something that's solid. So this would be like your second object, but it's not going to be moving. But it gets complex if you do that. So you're better off just using the formula which you're used to. So speed of separation, okay, is after the impact, right? After the impact of the wall, but I don't know what it is, so I'll just call that V. The speed of approach was 2.4, and that will equal my E, which is 0.6. So all I got to do then is to get the V, the speed of separation, this here after the separation from a wall, after the impact, is just take the 2.4 up and times by the 0.6. Okay, and I get my answer, which will be 1.44 meters per second.